Okay, so example number one, let's imagine a skydiver before he's opened his parachute, skydiver. Pardon me. So if you had any artistic talent, which I don't, you could do a drawing here. I'll try. So here's my guy in a parachute, whatever. Okay, but the idea is what I'm more interested in and what I would like you to get in the habit of drawing are these things called free body diagrams. Now, a free body diagram is just a way of keeping track of all the forces acting on an object. So in this case, we've got this guy falling through the air. I said his parachute isn't open yet. Forget about his parachute, all right? Well, let's think about this. What forces are acting on him? Well, probably he has some gravity. And this gravity is going to be pulling him down. So I could call this Fg, the force of gravity. And I'm just going to make up a number. I'm going to say that the force of gravity is pulling him down with, say, 600 newtons of force. But we know this isn't happening in a vacuum, so there is probably some air resistance here as well. So I'm going to draw some air resistance, but before he's opened his parachute, the air resistance is probably less than the force of gravity. So I'm going to call this a force of air resistance, F air. And I'm going to say that there's, I'm just going to make a number up, 120 newtons of air resistance. Now, if this were the problem that you were given, right, where it was told your force of gravity is 600 newtons, your force of air resistance is 120 newtons, you could be asked, what's the net force? And again, the way I think about it is who's winning and by how much. So of these forces, which is winning? Well, the downward force, gravity, is winning. So I'm going to draw my net force, which I draw next to the free body diagram as a double arrow. I always draw my net force as a double arrow to differentiate it from a regular force, which is a single arrow. So the net force is down, and how much is it down by? Well, how much is down winning? 600 minus 120 is 480. So my net force is 480 newtons down. So a correct answer for a net force has two things. It's got a magnitude, because net force is a vector. And remember, vectors have two things, magnitude and direction. So it has a magnitude of 480 newtons, and it has a direction which is down. So if someone asks you what the net force is, you have to include both these things. We can use this in other cases. So imagine, this time let's say a car on the interstate. And we're going to think about a car that's accelerating. So there's my car. But if I do my free body diagram for this, again, at this point, I'm gonna basically make up a problem for you. I'm gonna say, okay, well, this car has some gravity pulling it down. Let's say it's something like, let's say 9,000 newtons. This is the force of gravity. Now we know that it's not falling down, so there's this thing called the normal force going up. We talked about normal force back when we were talking about Newton's first law. So I'm going to call this Fn, the normal force. And I'm going to say that the engine is pushing it forward with an applied force of, let's say, 4,000 newtons. And let's say that I want to know what's the force of friction. And let's say that the problem also tells you that the net force is forward with a magnitude of 2,900 newtons. Okay, so if this was your problem, and you're trying to find what's the friction force, you're kind of doing the opposite of what we just did above, where you're saying, okay, the net force has to be 2,900. That means forward has to win by 2,900. So we need the forward, we need to know what friction is so that the forward force wins by 2,900. What are we going to do with these 9,000s? Oops, that's a 9,000. What are we going to do with these 9,000s here? Well, you'll notice this car isn't going up and down, and since it's not going up or down, these two forces cancel each other out. So the car isn't going up or down. It's just going to be canceled out. The car is only going to the right. So the forces in the right here, we have to say that 4,000 minus this friction force that we don't know is going to have to equal my net force of 2,900 newtons. And then this is just an algebra problem. So negative FF, if we subtract 4,000 for both sides. Let's see if I can do mental math. 2,000, 1,100, so negative 1,100 newtons. Did I do that right? Yep, I did that right. So if negative FF equals 1,100, negative 1,100 newtons, the force of friction equals 1,100 newtons. I just multiply both sides by -1. So that's another sort of problem that I could ask you. I'm going to give you one more, and then I'm going to have you try this, and then you can go on to the Check for Understanding quiz. So I'm going to say an object. We're not going to say what it is. I'm just going to say that, let's say it's got a force this way of 300 newtons, a force this way of 300 newtons, and we're going to go 100 newtons of friction, and we're going to say, what's this force? But we're going to say that the net force is forward with a magnitude of 500 newtons. Okay, take a minute and pause the video and try and answer that for yourself. And then I'll come back. I'll give you a second to pause the video. Okay, and hopefully you've tried this for yourself and we can see, okay, we want to know this force, which maybe I'll call this force, I'll call it the applied force. I have to know that the applied force minus friction, which is 100 newtons, has to equal 500 newtons. Add 100 to both sides, the applied force is 600 newtons. Now again, why did I ignore these two forces? Well, the up and down forces are canceling each other out. You can imagine this object, if I tied 4 ropes to it and I had 300 newtons up, 300 newtons down, this object's not going to go up or down. It's only going to go either forward or backward. In this case, it's going forward because forward is the biggest force. Okay, so go ahead. If you have questions, please email me or send me a message on Schoology, and then take the quiz.